All right. So today we're going to deal with adding and subtracting fractions that don't have like denominators. Okay, and again, should not be a big deal either, right? So remember that when you add and subtract fractions, you have to have like denominators. So let's just kind of give you a quick example real fast and see what you remember. So I'm just going to throw in a new page here. Let's say we were to ask you to figure out what is 2/3 plus 3/4. Well, you don't have like denominators, so you have to get common denominators. Hopefully you realize that both of these fractions can turn into twelfths. That's probably, not probably, that is the least common denominator. They could turn into other numbers also. They could turn into 24 if you wanted to. They could turn into 60 if you wanted to. Okay, but let's keep it as the least common denominator. Well, how do you get from 4 to 12? You've got to multiply by 3. So whatever you do to the bottom, you do to the top. 3/4 is equivalent to 9/12. 2/3, get that into twelfths, multiply the denominator by 4. Whatever you do to the bottom, you do to the top. So this now becomes 2/3 is equivalent to 8/12. So now really all you're doing is you're saying, all right, I've got 8/12, which is the 2/3 equivalent. I've got 9/12, which is the 3/4 equivalent. And now I have 17/12. And you're just going to leave it like that. You're not going to worry about simplifying it into a mixed number. It's not a big deal. Okay, if we happen to be subtracting these fractions, if this actually was what's 2/3 minus 3/4, well, we'd have the same idea. Now, if we made this as minus, this answer in subtraction would become negative 1/12. Okay, so don't forget that you know how to add and subtractions with unlike denominators. You find yourself a common denominator and you go. Let's go back to this first page for a second. All right, so to find a common denominator, you must find the least common multiple of both denominators, which is also known as the LCD. The least common denominator is the product of the factors of the denominator with each common factor used only once. It sounds kind of weird, but for numbers, you're looking for the least common multiple of the two or more numbers. In other words, your number has to be as big as the biggest or bigger. Okay? Least common multiple of variables. You're looking for the greatest power of any variable that exists. We basically need to make sure that the bottoms, the denominators, balance each other out, that they turn into the same thing. So if I take a look at this first one, I've got 5x squared and I've got 8x. Well, 5 and 8 aren't the same, but what's the smallest number they could both turn into? Essentially, I can start counting by 8s. 8 times 1 is 8. 5 doesn't go into it. 8 times 2, I guess I'll write this out. So I can count by 8. So I've got 8. 8 times 2 is 16. Well, 5 doesn't go into it. 8 times 3, 24. 5 doesn't go into it. 8 times 4, 32. 5 doesn't go into it. 8 times 5, 40. 5 does go into it. So right now for my least common denominator, or my LCM, I know that 40 is going to be the beginning of it. Now when I deal with the x's, well, the only way to balance these x's out, a 5 already has an x squared. If I can just multiply the 8 by another x, now my x's are balanced out, which means my least common multiple is 40x squared. I can get both of those things to turn into 40x squared. If I take a look at the next one, I've got 3 and I've got x, and then I've got 4 and I've got y. Another way to think about how to balance it out, well, this guy is missing a y, this guy is missing an x, but I'm not done because the numbers aren't the same. If I multiply that by a 4 and multiply that by a 3, now I have the same thing. My least common multiple, my least common denominator, is 3 times 4, x times y. They both can turn into 12xy. Okay, and that's essentially all you're doing. Let me kind of do that the same thing over here. That might actually make a little more sense. So what we're saying for this one is I've got basically 5 times x, and then I've got 8 times x. Well, how do I balance them out? This guy needs an 8. This guy needs a 5, but this guy still needs another x. That's where, and that might be a better visual, that's where this 40x squared is coming from. Now they both have an 8 and a 5 multiplied together, and then 2 x's. Alrighty. So when we're dealing with this skip this page. When we're dealing with adding or subtracting rationals with unlike, find the common denominator. Change each rational expression into an equivalent expression with that common denominator. add or subtract just like you do with like denominators. Keep change all with subtraction. Don't forget with subtraction, you got to watch your signs, and then simplify if you can. So if I look at this first one and look at my denominators, well, one's got a 3x and one's got a 6x. They're not the same. They both share an x, but all I would need to do is multiply this first fraction by a 2 on the top and a 2 on the bottom, which means I've got 14 over 6x. Well, now I've got common denominator with the original second fraction, 3 over 6x. I'm just adding, not a big deal. So my final answer becomes common denominator, 6x. Numerators happen to be like terms. There's your final answer, 17 over 6x. You are finished. Let's take a look at the next one. The first thing I'm going to do is put plus a negative. So I know I'm dealing with that. Well, I've got 5x and 3x squared. They both don't have the same bottoms. How can I make them the same? Well, if I multiply this bottom by a 3 and this bottom by a 5, they both become 15. I need to get the x's to be the same amount, which means if I multiply this bottom by another x, there's my common denominator, 15x squared. Whatever I do to the bottom, I do to the top. Whatever I do to the bottom, I do to the top. So what now happens is this first fraction now becomes 3x times 3, or 9x over 15x squared. My right fraction becomes negative 1 times 5, or negative 5 over 15x squared. We found the common denominator, which we knew. And now all I need to do is combine like terms. Well, my numerators are not like terms to begin with. I can't add them like I did on the other one, so I can't combine them. So really what ends up happening is this is just going to stay as 9x plus negative 5, or 9x minus 5 over the common denominator, 15x squared. That's your final answer. There's nothing else you can do. You can't factor that numerator any further. Let's keep on going. 2x and 7y, they're not the same thing, but what could they both turn into? Well, the 2 and the 7 can both become a 14, and they each need to have 1x and 1y. Easy enough. I'm going to multiply this first fraction by 7y, top and bottom. I'm going to multiply the second fraction by 2x, top and bottom. So the first fraction turns into 77y over 14xy. The second fraction turns into 8x over 14xy. That's the whole point. I do not have like terms in my numerator, so the final answer as one fraction is 77y plus 8x all over 14xy. That's your final answer. Can't simplify the top at all, and you can't do anything with the top and the bottom because you got a binomial and a monomial. Next one, one's got an a, one's got a 3a. Well, all that you need to do to get a common denominator is to multiply this first fraction by 3. And when you do that, you need to realize that that binomial up top has to get distributed by that 3. So what's going to happen up top is you've really got this 3 with the a plus 1 over 3a, plus, in this case, you've got a minus 3 over 3a. I'm not putting that one in a parentheses just yet because what I realize is I have to distribute in here. So I become 3a plus 3, and then I'm going to take the second fraction. I know it's going to go into the same numerator, right? Because as long as I've got common denominators, I can combine the fractions. And now what I see is I do in fact have some like terms up top. These guys can combine, and these guys can combine. So what happens in terms of your final answer, or I'm not sure if it's going to be final yet, but in terms of your numerator, let's get back here. Let's stem this up a little bit. So what's going to happen now is 3a plus a, the yellow highlights are 4a's. 3 minus 3 is 0. And I've got this 4a over 3a. But what I realize is these guys can cancel out, and this final answer is just the fraction of 4/3. All right, so take a look at that and make sure that you're good. We found the common denominator. We had to distribute on the top of that left fraction, the right fraction we left as is, combined ourselves with the like terms, and then simplified. Let's move on to the next one. Alrighty, so now we've got a subtraction problem again, and before I do anything, I'm going to keep change all. So this becomes an addition problem, this becomes a -4, this becomes a positive 8n. In terms of denominators, I need to have them both be a 4n. So I just need to multiply that particular numerator by 4, and I'm going to distribute all at once. Hopefully you're going to be okay here. This is going to become 4n plus 12 over 4n. This now becomes, right, within second fraction, this becomes plus -4 plus 8n over 4n. When I combine like terms, my denominators alike, I've got 4n's plus 8n's, or 12n's. I've got 12 plus -4, which is plus 8. This is one that I can actually do some simplifying with, right? Because my top has a GCF. My top GCF would be 4. What's left over is 3n plus 2 all over 4n. I'm only allowed to simplify monomials with monomials or bis with bis. 4 divided by 4 is just 1. So what happens is this final answer, I'm going to squeeze it in here, is 3n plus 2 all over n. I can't cross out those n's. The one n in parentheses is a part of a binomial pair. The other n on the bottom is just all by itself. Okay, so this should be enough to get you through the homework. Good luck.